And I believe we are now ready for our journey towards 6G in 2030, which is coincidentally the title of our next talk. Now, the market demands of 2030 and beyond will likely introduce new applications with more stringent requirements in terms of ultra-high reliability, capacity, energy efficiency, and low latency. And to share more about 5G evolution, his views about 6G and the future communications program at SUTD, I would now like to introduce our next speaker. He's an IEEE Fellow and received the 2008 Philip Yeo Prize for Outstanding Achievement in Research, the 2012 IEEE William R. Bennett Prize, the 2020 IEEE Stephen O. Rice Prize, the 2020 Nokia Visiting Professor, and the 2016 to 2020 Clarivate Analytics Highly Cited Researcher. Ladies and gentlemen, let's welcome Director, Future Communications Program, Head of Information Systems Technology and Design, or ISTD Pillar at SUTD, Professor Tony Quek.
Okay, thank you. Thank you, MC. I will share my slides. Really, thank you, Dr. Wong for setting the stage of 6G. I think it's exciting to really see so many interesting topics, and I think the promotion of there's a lot of fundamental topics that are still open to us. We need a lot of work in this research area, especially some of these topics will overlap with some of the topics I will go to mention later. I hope we can complement the vision and hope to promote this, especially for both international and for Singapore. So I'm going to step back a bit to look at 5G, then I hope to bring the journey slowly to 6G. We know 5G has just been deployed in around Asia for Singapore. Our deployment is based on the release 15. You think of most of the applications is about higher data rate. In the context of a 5G standard, it's actually called EMBB. What it wants to bring is actually have a high data rate for different type of applications. For example, mobile video, high definition video, mobile VR and AR. So this is one aspect, but there are actually two other aspects of 5G. They open up the vertical services. We talk about Internet of Things. We talk about even satellite just now in Dr. Wen Tong's talk. There's a lot of huge amount of applications that we hope 5G and 5G evolution can bring us, because this will set the stage to 6G. Because the question we want to answer is that with all the different technologies, how does the different technologies in the end serve the different vertical services that can help us? Because ultimately it's about improving the society and for sustainability of the earth. So to elaborate a bit more on this 5G standard. In the standard, there's a standard board is called 3GPP. What we actually have been deployed is release 15. There's a 16, 17 for those who are interested and look at different technologies evolution. Particularly 17 will have a lot of use case on 5G or 5G evolution. Release 18 has just has a recent meeting on this month. So if you look at the current standard itself, I'll just, you can look at the slide. This slide is actually also from Huawei. In the release 15, a lot of emphasis on EMBB. So to serve essentially the higher data rate. Then as we evolve, I think, so that's an important part of the evolution. So as we start to implement, let's say release 16, 17, then we will actually see the other features, the features that we are looking out, like the massive machine type communications, the ultra reliable low latencies communications that we hope to see in all more of the different use case. So I'm going to bring hopefully to the audience and to community that actually there's a important evolution. There is this 5G evolution that is from 2020 from now to 2025. In the standard context, that's like from release 18 onwards. These are also areas of research, areas where the community should also to think about as they look at how to invest subsequently in for 6G. Because as you see, there's a lot of different topics. But I think it's a progression process, especially for different depending on different companies, agency, or even the researcher. So I would just like to bring about a few trends we see, particularly especially for Singapore context. I think one thing we really want to look at is the use case, the 5G use case. So there are a lot of use cases, as I mentioned, release 15, 16, 17, depending on whether EMBB, whether it's for massive machine type, ultra reliable latency, the different use case. The different use case, for example, for healthcare, for your hospital, even for port and so on. When 5G comes in, what is the benefit or that it brings about compared to some of these services are using 4G? So you will take a few years to look at that, and what kind of new services or new innovation that we can actually bring about in this. So this is one stage, especially for Singapore context, to actually really look at this 5G use case. Then there's a few other areas which is very exciting. I'm going to talk a bit about this. A trend called Open Radio Access Network Alliance is OpenRUN. So the main concepts of this is essentially that if you look at the current ecosystems of whether it's 4G and 5G, there's a few big vendors that dominate the base stations. So with these base stations, the current system is a very closed system. So when you have a current system, a lot of times when you deploy, if you talk about vertical services, then you actually have to rely on a particular set of vendor from end-to-end system. But there's a trend to look at this open OpenRUN community, OpenRUN alliance. So the advantage, of course, currently is to reduce the deployment cost, to reduce the operating costs, where you make the 5G, let's say the base station or the end-to-end system, to be an open platform where it's modularized. So once you're modularized, actually you have the different companies that can come in to produce, to serve different parts. Then you integrate, it becomes a 5G end-to-end system. So system integrated is important. Of course, although it brings flexibility, there's also challenges, security challenges. How do you ensure different different module can actually be interoperability? So there's of course there's challenges, but that's a new exciting area that I will elaborate a bit more on that. And continue on that, we also see another trend in 5G evolution, particular around the Asia region, is this concept of a private network. So in the standard, they do have a band, they do have several bands that actually allocate for this private network for N79 or N78. I think in US and in Japan, they're using N79. So it's essentially is to speed up this push of vertical services. So in time, in some of these applications, for example, in a factory, they may not want to, because of maybe data privacy, because they want to have their own network, because the requirements will be different. They are, for example, the requirements on data rate, the requirements on latency, the requirements on reliability will be much different. So they may not want to rely on a mobile network operator to deploy for them. So they want to have their private network. So there's ways of doing that. Of course, one way is I can have a mobile operator that provide this through network slicing. So network slicing is one technology to do that. I can have a private slice for this. That's one model to operate. Another model is actually have your own private network. And that is sort of a business case for this OpenRUN consortium, where they want to push, we want to deploy such a private network at a much faster and a lower cost. This could be one proposition. So there's one direction to look up for. Another direction is the unlicensed band. So there's one direction, if you look at the trend, even Dr. Wong talked about going up to higher band. But even at nothing's for free. When you go up to higher band, you will see that basically your coverage essentially is going to be much smaller. You will not have a larger coverage. So in the sub 6 GHz where you have a much better coverages, you want to actually see the possibility of using unlicensed spectrum. So how does, in the 3GPP, there's also a trend to look at unlicensed spectrum. So this is one direction in this 5G evolution to look at. If you want to use unlicensed spectrum for your particular service, how do you ensure it doesn't hurt the services of the unlicensed? For example, you want to use, even you want to Wi-Fi, you don't want to ensure you cause any too much interference to Wi-Fi services and so on. So I think that's an important area in this 5G evolution to look at. So to make the point more specific, particularly for those who are working in this area, as I mentioned, the new spectrum to look at in the sub 6, for example, at 6 GHz, to look at the possibility of use sub 6, to look at 6 GHz for another candidate for 5G evolution. So there's a few band. Of course, this has to go through standardization, but you need to do channel measurement. You need to understand the properties of 6 GHz and how does, and to think of that. So in the future, if you have 6 GHz, you have around 3.5 GHz, and you have probably some regions would actually second generation or third generation will phase out. You have actually much lower than below 2 GHz. So you have a few band. So when you have a few band, then you have to look at in your system. In your system, how do you ensure at your system level, when you have this 3 band, how do you operate this 3 band in an efficient manner? For example, your services for handover, even to bring in AI, how could this help you to ensure you have this very efficient spectrum access? So this is also related to this fast and efficient spectrum utilization. Massive MIMO as is one important technology as we see in 5G. FDD is still very because the advantage of using FDD is that uplink and downlink are different frequency band, uplink and downlink. Of course, the disadvantage you have to do a lot of channel measurement, but with massive antenna, there's too many channel measurement you need to do. So can we exploit this partial reciprocity using AI to do that? So and I think 5G evolution, we could see some of this. Sub 100 GHz fast and efficient spectrum utilization. So we still see in the community there's a lot of interest to from millimeter wave move up to terahertz. But I think my general sense, we see that depending on the different, some people want to go up to 300 or 200 and so on. A few questions I think we need to really carefully answer that. First of all, it's essentially the market. Essentially, the business model needs to be clear as we go up so high. What is because you have a shorter range. Imagine you will have to deploy a lot of these terahertz type of network. And once you deploy, it's not about radio access, it's also about your backhaul connecting to them. So the deployment is very, very important. The deployment, the economic model is have to be rethink carefully. Second is why particular band. For example, there's news you can see recently, there's results at 140 gigahertz, there's different, and why particular that band? Of course, we need to really understand in terms of the channel measurement. Of course, at the standardization body, they also have to go through the standardization, but also, of course, also related to materials. So at this point, I think if you want to go up to such a high band, in terms of feasibility, maybe at the sub 100 or below 100, I think there's still available quite a big bandwidth to look at. Looking at that and also looking at the materials aspect, the ADC aspects, and how to actually, if you have that band, how to use that fast, efficient spectrum utilization. Another, as I talk about use case, why use case is very important. There's a lot of interest in this AR, VR user experience. I think this pandemic if you have a chance to be quarantined in hotel for many days, like 14 days or 21 days, I think staying alone in a hotel is a miserable experience. I think if you have the technology to have this immersive experience or AR, VR, holographic, have another person or virtual person talk to you, have meetings, I think the experience will be very different. So the question is that if you have all this AR, VR, the user experience, then I think the question is that, of course, you will expect that all this service will utilize a huge amount of resources. So how do we do resource allocation or user experience optimization? And we may have to actually step back from what we have done conventionally using, for example, channel capacity or using. So what is the right measure for that? Because a lot of all these measures is related to your user experience, right? Your user experience, how do you actually measure that user experience and capture that in your objective function or in your function to ensure this service really is aligned? So I think that's a very important question. So I think the way forward, the KPI should not be a single metric, but it's going to be a bag of metric, and that bag of metric is mapped to your use case. So which means that the way forward is about use case. So identify the right use case and to map back to a bag of KPI and the technologies. I think if that is very clear, then it's then for industry point of view, or even for MNO, then they're very clear what type of technology they should invest in. I think Dr. Wong also talked very important about this network assistant. That means the use of this side link where user cooperation, because if you look at a few trends that we can see currently in terms of the UE, we see that even in the release of the Apple phone, the new Apple phone has the possibility of ultra-wideband. It's not just for localization. It's also can be used for D2D, user collaboration for coverage and capacity. We'll see that, but that is not network assisted. So what we can see in the future is that your network, whether it's at the small cell level or your base station level, need to be coordinated in this user cooperation, which is not a very easy process. It is essentially, you imagine that if you have such many links and all the links are very dynamic and they do not last very long, very short. It's very dynamic. It's not a fixed link. And to get the network to be assisted, also you want to reduce the overhead. So it's a trade-off of that and how to manage this in an efficient and sustainable model. I think there are questions we need to answer that. Massive machine type IoT applications, high throughput IoT applications is very important. So we talk about IoT for many years, but if we think about the IoT, a lot of very exciting IoT applications may not be where the human populations are a lot, because in a lot of contexts, you see IoT, you need coverage. So the current base station terrestrial network provide the coverage, but some applications are not where all the base stations are, cellular base stations. For example, applications related to the sea, out in the sea, you need that. You need IoT applications, but of course the base stations is not there. This is one. So which means that satellite will be very important, right? So the integrator of the satellite and terrestrial, I think, is one very exciting area that can actually provide where the base stations are not covered. So you actually want the communication to be actually close to where the machines are and not to where the human are. So it's just very different between where we have done, have deployed our cellular context. So satellite will play a very important role in this satellite IoT. I think in the standard, they are looking at that. Then if you have a massive, but when you're high throughput, then I think the low LEO will be exciting area to look at. Autonomous vehicle, 5G for V2X, I think we are all, there's in the standard, there's a lot of development on that. I think at the end, we will have to see a lot of mass deployment, because once we have a mass deployment, I think there will be a lot of new challenges that we look at, because the use of, because a huge amount of data need to upload to your radio site unit, your base station. Then I think that is also something to look out for, especially for this 5G evolution, which I think is important. I've mentioned a lot of use case and use case study and deployment. mainly because if you look carefully of how all this generation has been involved, whether from 2G, 3G, we always have this chart of this KPI. And we see that the KPI chart is actually growing as you go for one generation to another generation. Is essentially you're actually pushing to limit. So as you push this limit, so what will happen since starting for free is essentially you imagine that you're actually creating a systems that is going to be more expensive. Your systems that actually going to meet all these very extreme KPI. But at the end of the day, what is the use case? Some of these use case may only need a few of them and may need only maybe 50% of this particular KPI or even 20%. So essentially, what is the best operating point for particular service? So which means that I think one evolution as we move towards 6G, especially we need to take care of this 5G from 2020-25 evolution, is this use case study deployment, trying to understand that so that you guide us in the future how to, even in the standardization or in the technology we choose, how do we design particularly well for particular use case so it's sustainable? If not, I think it's a bit difficult because it's actually some conflicting interest. Then of this OpenRUN and private network, which I mentioned before. So I'll elaborate on this. So this is something you can look at LinkedIn or internet. These are some of these areas, some of these recent news, whether it's Intel is also moving into this area. Rakuten deployment in Japan has been based on this ORAN concept. There's working with overseas vendor. Then in 3GPP, there's also movement to incorporate this community inside. Nokia as a company that traditional vendor of a closed base station systems are also looking at that. But of course, this is one area to look at. Of course, at the end, it will be the business that drive whether this technology will be the mainstream. But it's something actually to look out for. So since this is a technical talk, I'll just give a glimpse of what it actually looks like. For your interest, if you're interested, you actually can download from this OpenRUN consortium. This is a white paper. So this is what the base station would look like. So essentially, it's modularized. So you have a radio unit. It's like an antenna element. You have a data unit. Then you have a control unit. So there are interfaces connecting to them. Some of them are fiber. All these are actually indicated in the standard, so that for vendor to actually deploy this. So that what interestingly that there's actually two very important modules that you can like this near real time RAN or radio access network intelligent controller RIC. Then there's a non-real time radio RIC. So this is where possibility the use of your machine learning, or you can call it machine learning or you call it AI. I think machine learning is more appropriate. Machine learning tools to be there. So having that, whether you want to do it for scheduling, whether you want to control for your interference management or even your slicing capability, there's possibility that actually you can actually create that and to implement. Even in your, if I want to deploy this as a private network. So we can see that, oh, there's a chance to actually, and not going through a single vendor closed system. So something to look out for from my perspective, okay? So that hope that set the stage of 5G and 5G evolution so that it's important that there's a lot of things that I think we should actually do in this 5G evolution that can help us to better understand what 6G or what we should invest. So I think the work of 6G is actually, the next few slides will be easier. I think Dr. Wong has really set the stage well for me, and a lot of topics actually has overlap. I think trustworthiness is important. We want actually a communication, whether computing or communication for a particular service, you want to ensure that privacy is ensured, your data is protected. New services, new demands. What it is, something to look out for, whether it's for AR, XR, new sensors, integrated of sensors. I think connectivity is going to be very important. I think there's also an interesting talk later of the day on holographic. I think holographic will be very exciting. sustainable. I think with all the trend of sustainability, you want to ensure your deployment because particularly as we see the trend of moving to a higher band means the cell is going to be very smaller. If you deploy more power, it's going to consume power at different level, processing power, computing power, so there's different. So you have to ensure that actually it's sustainable while you enable your society with new services. The use of AI, I think AI is going to be very big. So that the services that, because we have a huge amount of data, you have to process your data. The use of new learning models, I think is important. Deep learning, of course, is one way, but the general trend that you look at that you require to crank a lot of data, but sometimes essentially the feature that you actually can extract only exists in a small set of data. So essentially you waste a lot of computing power actually to do that. So incorporating new type of models to ensure that this is sustainable actually is important. I think federated learning is of course one direction to have a smaller models and distributed. So in line with that, so 2030 is sort of the stage that a lot of in the community or in the 3G community has said, okay, in 10 years time, 6G will be deployed in 2030 or maybe earlier, depending on how fast the standardization will go. Likely in the current status, release 18, I think this year we have started 2021. So we see that the standardization of 6G will likely be around end of 24 or 25, maybe around that time, which means that if we are looking at the research, I think in parallel with 5G evolution type of development and research, from now to 2025 or 2024, these are the time when you really want to do your pre-investment on 6G research, because the working item will actually be identified for standardization about end of 2024 or 2025. And another important point to look at is this spectrum. So there's two very big events, WRC 23 and 27. So these are the likely event where standardization of the spectrum will be done, whether it's a 6G spectrum, the higher band spectrum, or particularly your satellite, your low orbit satellite or your inter-satellite communication, or even your drone aerial platform. What is the spectrum you're going to standardize? So this is very important because this will drive the kind of technology and the investment that whether that industry or agency will actually put. So there's a lot of initiatives on 6G. ITU has said this. Hot topics around the world. Many information you actually can find on the internet. Even the first talk by Tuan, it's exciting with all the different technologies. Different around the region has invested a lot. In China, they started in 2019. Finland, I can remember Finland has a 6G flagship. It's an 8-year program. Taiwan, Japan, Korea. Singapore will launch a related initiative and will be announced in July. So I think from a Singapore context is that I think we have to be a part of this, because as you see, what's very clear is that connectivity and communication is going to be more than just a pipe, provide all our vertical services. So having that capability would put us in a stronger position to be a big part of this whole ecosystem and industry. So I'll just share some of these activities around the region. Of course, due to time constraint, I cannot do for all. I'll just show a few. So this is activities in China. So there's this IMT 2030 promotion group. So it's a consolidated national effort. So there's a different, which is very clear. So you can actually find all this information. So there's a requirement working group, tech working group, network working group, spectrum, standardization, and there is so it's a very holistic and effort at the national level, where university level, chipset system operator, research institution, and I think they do identify some of these technologies they look at through grant call and so on. If you're interested, you can look at the website MIT. So there's also international partners inside all this initiative. In US, likewise, the same Next Generation Alliance, they started look at the 6G. In the NSF, there's also grant call related to this. So interesting companies, you'll see Facebook, you'll see Google, all these are also interested in this area. As you see, why particular, it's not just constrained to this telco, because as you see, what is important, 5G is the first step. You see in the next generation, it's all connected to all the vertical services. So you see communication, computing, all integrated. You see sensing integrated. You see all the new services. EU, likewise, I think this is a new project. It's called Hexax. What is exciting, you see, is that the definition of this 6G, they define as a digital world, physical world, human world. So you see that that is something that why XR, AR, VR, immersive experience, the cognition experience will all come together. And actually, when you come together, this is essentially, it pushes the limits that is beyond communication. So you really need to understand the context. What are you transmitting? The sense will come in. So it's an exciting, really new area. A lot of open problems for people to look at. Trends in 6G vision. If you're interested, there's many materials out there around the region, around the world. So it's an exciting period for people who will work on this area. Okay, yep, some KPI in this 6G flagship. I just for your interest, this is not confirmed at the ITU. It's just a table that I got from this 6G flagship white paper. So what is clear, as I mentioned just now, that so this is one trend we see, that in the 5G you have this KPI, different KPI, peak data rate, spectral efficiency, for example, connectivity, energy efficiency, and so on. So so this one, of course, this is one approach that we see in different groups are looking at, is to push this limit. But if you carefully look at this limit, let's say 1 terabyte, some of this service, let's say in a manufacturing, I may not want to have such a peak data rate. My reliability, yes. Latency, yes. So I think, so that is a question that I think the community need to think about. How do we have a flexibility or programmable sort of system able to adapt and not be fixated by trying to push all this limit? If not, we will create a very expensive type of a network. This exciting, some key technologies, I think I just want to particularly bring about. One of them is called Internet of Senses. So interesting, I think Dr. Wong talk about this integrated sense and communication. It's exciting because if you think of it, how do you actually communicate your sense? Yeah, because humans have all these senses. How do you actually, if all these senses of your sense and your friends or your social network can be able to communicate, what is the architecture? And what is that network, whether it's from network architecture, what is that technology that able to create that? Because once you're able to actually create that, you actually solve a lot of these problems we have in this pandemic, where you need to lock down, all these isolation problems, all these stress problems, where you're not able to connect with other people. That, because at the end, humans need this social communication. You need this community. And hopefully 6G can build these key technologies to prepare us, so that if happen that another pandemic comes in the future, actually we are well prepared with all this technology. Many topics, I will not go through all of them. I will just, due to time constraint, I will just elaborate a few of them, okay? So short range connectivity, as I briefly mentioned, so it's very clear in the standard now, we can support up to like 52 gigahertz, and we see even in the trend of future release, we will move up to a higher band, terahertz band. So this is something if to look carefully at, because this is closely linked with hardware. As you go up higher band, the challenges on the materials, the challenges on your AD will be tougher and tougher. The right materials, the cost, the deployment, which actually band to look at. we really have to think carefully on that. And related to that, I mean, propagation loss, as I mentioned, is a very key factor. So your proper careful channel measurement, all this, and the use, I think antenna technology is going to be very important. Your integrated antenna, your programmable antenna technologies will be very, very key in this particular area. So hardware will be going to be very, very important. The analog communications, because you may not want to do everything on digital, hybrid type of hybrid technology, hybrid beamforming will be important. So back to this analog type of communication, will be actually very important to look at. And deployment, we have to always think carefully as we try to deploy, whether it's for reflective intelligent surfaces or this high short range connectivity technology. Deployment is very important, because at the end we have to look carefully at the constraint of this technology, because all this technology will have a smaller coverage. So where to put them, where the needs are, where to put them, and you cannot massively deploy, because that will have an implication on your backhaul. Backhaul, if you're going to have whether it's wired or wireless, it take up resources. Scalability, you want to integrate, you want to ensure your access and the backhaul is an integrated type of design. Your capacity could be a limit, because imagine you have such a high data rate at your access. The bottleneck cannot be at the backhaul. So the backhaul also has to keep up with that requirements on your data rate. So all these are important issues. Intelligence will be important into this configuration, the handover, because of the fact that it's a very, very small coverages, the seamless handover. And the questions that for different agencies or even the operator to carefully look at, as we move up to this higher band, if all the operators wants to have such a huge amount of bandwidth, do we have that sufficient bandwidth for all of them? So what is the policy, or what is the mechanism to do spectrum sharing? Because at the end of the day, you think of it, not some of these cell may not have much traffic, so you're actually wasting that spectrum. Something to look at, and how do intelligence play a role in managing this sharing will be very important. I've done some preliminary work which look at some small cell backhaul, but I will not elaborate, but we need to look at that. Wireless backhaul, I'll just go directly to some of these topics due to time constraint. So access backhaul integration, as I mentioned, talk about. Deployment operation is important. The type of backhaul technology not necessarily fixed. What type we could have wireless, what type of backhaul we can actually use millimeter wave also. So which means that there's also possibility of autonomous backhaul selection and configuration. How to actually do that depending on your weather, depending on the different weather conditions, depending on also requirement and your demand. So aligned to what I've mentioned before, massive deployment, density, scalability is in the design, infrastructure, spectrum sharing can reduce costs. So how do we actually look at that? Is ORAN and a good solution for that? Something to actually ponder, although we don't have actually radio unit with that capability yet. As I mentioned, integrating intelligence to that dynamic access backhaul will be very key, because we know that traffic will be the key to look at the utilization of this. Definitely, depending on some of these applications, we definitely see that downlink uplink traffic will be highly asymmetric. If you're highly asymmetric, how do you actually deploy way advanced? So some of this dynamic intelligence will be very important to help us to actually design something more sustainable. What I will not just mention this, I will just continue so that I can complete on time. So massive IoT, massive URLCC. So in the current standard, we do have massive IoT. URLCC is not actually massive yet. So, but if you think of autonomous vehicle as a good applications of using URLCC, ultra reliable, low latency. So imagine down the road, let's say 2030, where we have a lot of autonomous vehicle, it's a massive URLCC. So in our current development of URLCs, can we actually support that? Maybe not. we need to be better than that. So what are the new technologies and understanding to do that? How to enhance latency, positioning, connectivity? How do we efficiently use the higher band to do that? Some of these massive IoT applications, power is important. The use of energy harvesting, the backscatter sensors, the sensor, and we see the trend of integrating sensors and communication. So we have a huge amount of sensors, so energy will be very important. At the end of the day, when you talk about IoT, all these applications, if you look at the protocol itself, it's actually a lot is based on random access. So, but fundamentally, if you have random access under massive connections, and a lot of these applications have delay constraint, and it's a challenging problem because a lot of current protocol will not be able to accommodate this, and you will cause a lot of problems in terms of performance. So essentially, if you think of it, site information will be very key. So site information of your position, information of your traffic, information of semantic, information of that will help all this even protocol to actually efficiently utilize their resource. So definitely we want to imagine that in the future, your user, your UE, your handphone, and your base station, whether access point, will be more intelligent and more powerful. There's possibility to exploit this capability to help us to solve all these access problems. And end of the day, you think of that, there's a lot of fundamental theories that we do not understand. So there's a lot of room for the community to really think carefully, right? All this trade-off, energy, delay, capacity, reliability, the fundamental system level trade-off is not well understand. So we have to look at that large system type, because a lot of problems we face will be based on large system. Traffic is dynamic. There's different form of intelligence. The interference is also dynamic. How to actually have a framework to understand that is something for the academia to carefully to look at that. I will skip that and I will go to continue to look at interesting area. Software-defined radio will meet software-defined network. We see the trend of this slicing programmable at the core network. We will see that because of the applications we talk about, the future, you want to have flexibility. You will see that the radio or the access point will be more programmable. We will see software-defined radio incoming. ORAN, you see some of this trend coming in. So likely we'll see that this will meet together, the software-defined because then it will end up become a very highly flexible agile network. So to move to that stage, a few challenges we need to tackle. So one challenges to look at is this virtualization. So the integration of this network and RAM virtualization. It's a challenge problem because the advantage of just doing network slicing and not do so much RAM slicing or RAM virtualization is that because the number of parameters that you can tweak, the number of information you have. So once you do this integration, you have a very challenging multi-time scale, multi-large scale optimization problem. You have a big area you need to control. How would AI and how will intelligent controller come into play? An intelligent controller that is smart enough to translate the key parameters or the key information back to the network slicing part. So I think that is something to look out for. Incorporating machine learning to all these optimization or resource allocation problem. We have huge amount of data, but we cannot afford to do the conventional approach of trying to crank all the data. How do intelligent technique to actually help us to reduce the search space? How do we efficiently incorporate this some model-based and model or knowledge-based and data-driven method together to ensure our system is actually sustainable, it's still robust, and we still can understand the results that all these machine learning crank out. And service multiplexing, because at the end of this day, this technology is to provide services. So some of these services you may want to multiplex with that. Okay, I heard the first bell, so I'm going to skip network intelligence. I will skip that. I just want to maybe emphasize just one point. So Federated learning, I think we have mentioned this a few times. So as we want to bring machine learning as example into the communications, we actually also need to think about the constraint. So as example, if you want to bring this federated learning down to the access point or the user side, the effect that we are going to transmit this over a wireless communications link, the effect of interference, the effect of power constraint, all these constraints need to come in. So this need to incorporate into my machine learning design. I think that's important so that my scheduling mechanism are well designed, tailored for that. Something for community to look at. Internet of Sensing, I think Dr. Wen Tong talked about that. So this is a very exciting area to look at a lot of fundamental problems that are missing. So sensing control integration, you imagine there's a lot of noisy and massive feedback. And if you bring security in, there's a lot of issues. How do you actually automate through AI, but then you don't overtrain? And that's something to ponder. Semantic communication, I think, is an exciting area that now we look at. This is actually one way to actually redesign our communication so that in the future, because we understand the context, the semantic that we are, and if there's a certain service that the transmitter and receiver only communicate based on a certain context because they understand the context well. So then the way you design this communication could be very different. It could be based on a common codebook. If it based on a common database, and that will help us to reduce the way the reduced amount of redundancy that we injected in our conventional communication. This is my last slide. So it's an integrated space terrestrial. It's a very exciting area to look at because it's beyond just ground and satellite. So there's also an airborne network. So it's a multi-layer heterogeneous network. So there's airship, there's aircraft, there's UAV. You could have, so imagine the notion of this side link could be in here. This will be a truly global coverage, anytime, anywhere, connectivity. But the challenge is highly complex because you have to integrate across different type of network, different channel conditions, different constraints, different power constraints, and it's across the globe. So it's a very exciting open area to actually look at. And I'm on time, so this is my last slide. So from particularly, I want to mention that really, we look at whether 6G or 5G evolution, connectivity and communication will be a backbone, especially as for Singapore context, as we want to push for smart nation, digital economy. So, and the journey to 6G starts now. And thank you for listening. Thank you very much.
Thank you so much, Professor Quek, for taking us on that engaging journey towards 6G. And we'll now move on to the question and answer segment. For those of you who are watching right now, don't forget to enter your questions into the Q&A tab or box, all right, in the platform. Now we have this question from Shmuel Yerushaimi, and the question is, what exactly are the advantages of 6G in relation to 5G, and how will 6G technologies improve the functions of different systems? What are your views?
So I think it's a good question because first of all, we do not know what is exactly 6G. So that's why I think what's important is this evolution that will help us to actually really understand what we will see. So this is sort of the first attempt when compared to 4G that a generation, let's say 5G, we talk a lot of use case, vertical services. So once we actually, this evolution, understand the different use case, we will understand the different limits of that. Once we understand the different limits of new services, new requirements come in. And that will set up what 6G is. At this stage, we see a few, let's say, service that cannot be done. Let's say Internet of Sense. How do you actually exchange sensors? Right? You want to, if you are quarantined, you want to talk to, how do you actually translate this emotion? I don't think 5G can do this. So a lot of exciting things that are still open for us to do.
Thank you so much, and I hope that answered your question. We have another question from our audience, And this question is there a role for TV white space in the 5G evolution? That's part one of the question. And there's a second part that says, do you see a role of Singapore scientists in pushing the LEO or LEO 6G frontier forward?
Okay, I think the first question, I briefly talked about this unlicensed spectrum, right? So as we look at the different services, so as we explore the different use case from now to in 2025, we will actually will likely face a scenario where certain services will require the long distance coverages of TV white space, because a few of these bands that they have are very good for coverages. So the use of unlicensed spectrum, I think is important to actually look at. Of course, the question is how do you have a system to actually efficiently able to spectrum access that, and to ensure that because of extensive coverage has advantage and disadvantage, because it could cause issues to our neighbors, because so close to a lot of neighbors. So something that is at the policy level. So that's one thing to actually look at from both technology and the political policy level. So the second question that I have is on the role for Singapore is let me see.
Can we have that question back again so we can see it one more time?
I can see.
Yes, the question is, do you see a role of Singapore scientists in pushing the LEO 6G frontier forward?
Yes, I definitely see that Singapore has a huge potential. Mainly because I think we are at least in the equator. So I think we have potential to set Singapore as a future satellite hub. So because once you are a future satellite, we can actually serve a lot of services around the Southeast Asia region. And a lot of times when we talk about this satellite or this stage, there's all this standardization body, and I think Singapore has always been a very neutral player. We want to serve a lot of all our neighbors, essentially also to help our economy. So from a political and motivation, I think we have that potential to do that. And we do have a lot of local companies starting to look at that. We do have our even government agency. I think EDP has an Austin program that look at that. So I think we have many parts that can come together so that we can contribute in this direction. So I'm positive that we can actually contribute in this particular area in the long run.
That truly sounds very, very exciting. This next question, Prof, comes from Melvin Kwan. And the question is, how will cybersecurity be embedded in the 6G design and architecture? And how would the trade-off with performance be handled? What do you think of this?
It is a very difficult problem. First of all, we do not know the architecture of 6G, right? But what is very clear with the current trend that we look at, what's 5G talk about, with all the issues of security and not trustworthiness, one key factor that we can foresee as we move forward to 6G is that the requirement of openness and trustworthiness in the system will be important. So that's one. And another area why there's also a trend to push this open platform, because it's based on open architecture. A lot of this is not a closed box. That is also one way to look at how it can, that's another direction. Of course, it really have to depends on how the business, how the industry will look at that. So that is an approach that the security, of course, can come into this open system because it's a very open platform. But 6G, I think, is still an open problem for us to look at that. Yeah.
Very good. So some more questions. I got to tell you that this whole discussion is really exciting, and we've got lots of questions from our audiences. The next question is from William Lau, and it says, is Li-Fi, L-I-F-I, Li-Fi, already a form of 6G? Is it?
A form of 6G. I think Li-Fi technologies is already exists. I mean, we do have Li-Fi technologies. I think at the end, why I always mention services, right? Because at the end of the day, whether I'm 5G or 6G or whether I'm 4G, it actually is the services I as a service provider or even my or even the industry, I really at the end don't care. It cares about my cost, my deployment, and my efficiency of my delivery of services, whether it's 4G, 5G. Li-Fi has its advantages, right? It has a downlink. You know, lights are everywhere. Indoor is one. Outdoor is an issue. Then once you have multiple light, the interference issue. So a lot of technologies has these different advantages and disadvantages. I think at the end of the day, what we definitely see is that the use case and a system integrator will be the key. Once we understand the different use cases, then there's a whole bag of technology. At the end, what I see is that at the end, I care about what is the key what is the key KPI, not just one, a bag of them. Eventually, to meet that, what is the best integration of the different technology that come together to serve this at a low cost? I think that's what we see. So Li-Fi is definitely one of the technology, but I do not say that it's going to be 6G because a lot has been done now in Li-Fi.
Fantastic. Yep. We've got about under 8 minutes to go, and we'll see if we can squeeze in just 2 or 3 more of the questions from our audience. This next one is by Diana R. And the question is, what is the future of CRN-SDR? What do you see, Prof?
So what is, let me see, what is
CRN?
Oh, there's a lot.
What? The future of CRN-SDR.
Oh, okay. So it's about connective radio and software-defined radio. All right. So I think so connective radio actually is a term that has been out there for many years, right? Some people interpret this as AI for communication. You can interpret that. As I mentioned, AI is going to be a big part of our evolution down to 6G because of the context of the massive of data. The network is going to be very complex, so the intelligence will be there. So you'll see definitely a part of that. Software-defined radio will be there because you want to have some programmable capability at your node, adapting to different services. So I briefly mentioned about a possibility of software-defined radio together with my software-defined networking. Hopefully come together, but complexity is an issue once you become so open and so programmable. Many things you need to optimize. So it's actually a lot of trade-off. Yeah.
Thank you so much for that answer to that question. Here is another one from Shruti Dave. And the question is, for 6G, will transmit antenna selection with massive MIMO work to achieve higher energy efficiency? What do you think?
I think this is probably a 4G type of or 5G type of question. Basically, in a 6G context, I think they will be looking more than this. I think if you think about massive antenna, whether you want to do transmit antenna selection or so on, I think so there's many schemes that propose to do that. But a lot of massive MIMO challenges that we see currently now is actually when you deploy this type of technology, the cost is very expensive, right? So in terms of the ADC requirement and also to do the alignment and so on, I think these are the challenges, but this is just one scheme. Yeah. Because to think about energy efficiency, also need to carefully think about the hardware. Yeah.
That's very true. Yeah. And we have some more questions coming in. This time, Prof, this is from Sadiq. And Sadiq says, this might be a concern for some people out there. And he asks, Does 6G impose any health problems on society?
Okay, first of all, we do not know which spectrum that 6G will be actually allocated. So I think there's no connection to health problems. We do not know actually. I think there's a lot of even arguments on 5G deployment in Europe, where they don't want the base station to be very close. But what we can see is that as we move from one generation to another generation, the power consumption or the transmission power is actually it's actually going down. It's actually we see that the energy efficiency is actually improving at a factor of 10 or more than, depending on the deployment. And if we go to for example, if we go to a higher band with a smaller coverages and with very sharp beam using antenna technology, direction antenna technology, I don't see that will be a big issue lah. But this is something too early to discuss at this stage. Yeah.
Thank you for expounding a little bit on that, Prof. One last question, that's all we have time for. And this last question is from Muhammad Ilyas Katak. And the question is, regarding wide-scale commercial deployment of collaborative autonomous vehicles or CAV, how much collaborative autonomous vehicles is commercially deployed till date worldwide?
I have to say I have no answer for that. Yeah, so I do not have the figures on that, and yeah. So but what I can see currently is that there is some trend of doing a lot of trials. What I understand, there is trials in a lot of especially in Asia, because a lot of regulation is easier. It's not just one vehicle. We see a lot of activities, particularly in China, a few highways, Hangzhou, trying to do large-scale highway or different region of this large-scale autonomous vehicle deployment. So I think at least for the next few years evolution until 2025, we will be able to see really large-scale sort of deployment. Not a single like pathway for the bus type lah. So it's actually on the highway, particularly in Asia. That will actually use some of this 5G or the V2X type of technology. So it's exciting to actually look at that, to look at what the challenges that they have, and so that it will guide us as we move forward to the future generation.
Thank you so much, Professor Quek, for your presentation and, of course, answering all those questions of our fellow explorers who are keen on embarking on that journey towards 6G. And you know, I feel all ready to take on 2030 right now with this morning's talks giving us a roadmap into the future. But before we do that, let's go for a little lunch.